Done copying the question? Guys, be on time from the next class. If it starts at 10:15, so you have to be at 10:15. Do not delay, okay? Because we are very much lagging in the syllabus. We need to pick up our speed.
Sir,
Hmm.
that mole fraction, how to find, I don't know, sir.
I think everyone has copied the question. How many constituents? 3 constituents, right? I can copy the same thing. Okay. So how many constituents are there in this problem?
3, sir.
Okay. So 1, 2, and 3. Okay. So is it better that I put it in a portrait mode? Which one is better, the landscape one or the portrait one?
Landscape, sir.
Okay. Okay. 3 constituents are there. What are the different gases given?
O2,
O2 is given how much? Percentage by volume?
30.
This is by volume, guys. Okay. Whatever he has given up till now, it is by volume. How much?
30%.
30%. Okay. So if I convert into percentage fraction, I should divide this by 30. It will become 0.3. That is 30 divided by 100. Next gas,
CO2.
CO2,
CO2. What is the given percentage by volume?
40, sir.
40%.
40%. So if I convert into percentage fraction, it is 0.4.
0.4.
0.4.
Exactly. Next gas,
N2.
N2. Percentage by volume.
30%.
30%.
So it is again 0.3. Now I need the molecular weight. What is the molecular weight of oxygen?
32.
32. Okay. Next, what is the molecular weight of CO2?
44.
44.
44. N2,
28.
28.
28. You need to remember this, all of you. Okay. They will be not giving in the question. You need to remember these values. Okay. Now, A cross M, 0.3 into 32.
9.6.
9.6. Zero point 0.4 into 44.
17.6.
17.6. I need others to answer. Everyone should answer now. Zero point 0.3 to 28.
8.4.
8.4.
8.4.
8.4. Now I'll be asking individual wise men. Now I need to calculate the mass fraction. Is it Abdul Rahim? How am I supposed to calculate the mass fraction of this?
Yes, sir.
How will I calculate the mass fraction of gas A? So I would name this as gas A, and this as gas B, and this as gas C, like this. Okay. Now I need to calculate EMF of A. So how will I calculate this? Which is this?
Mass of given mass, right? Total mass.
Yeah.
Given mass by total mass.
Even mass by total mass. For the total mass, I need to summation all this, right? So it is sigma
Yes,
A
sir.
cross M. So how much is the value? 9.6. Abdul Rahim, you have to see me the answer. So 9.6 plus
Yes.
17.6 plus 8.4. What is sigma A cross M?
Given mass.
Yeah? How much? How much, guys?
35.6.
35.6.
35.6. Sir,
Okay.
35.6.
Okay, 35.6. Suppose if I want MF of A, what should I do? It is nothing but A cross M of A divided by total, which is sigma A cross M, right? So A cross M of A is what? 9.6 divided by sigma A cross M is 35.6. Now give me the mass fraction.
0.269.
0.269.
Point four nine
Similarly,
four four.
0.4944. Very good. Mass fraction of C.
0.239.
1, 2, 3,
0.235.
3, 3, 6.
Very good. Now, the percentage by mass, what you have to do, you have to multiply all these values by 100.
26.9.
Exactly. So 26.9, 49.4, 23.5. If I add these two again, it should be 100%. Then your gravimetric analysis, what you have done, is absolutely right. Okay. So gravimetric analysis is done. So this particular thing here, I have calculated. Okay. Next, I have to calculate this, which is the molecular weight of the mixture. So how I'll do it? So molecular weight of the mixture is given by what? 1 divided by EMF of A divided by capital MA plus EMF of B divided by capital MB plus EMF of C divided by capital MC. Just substitute the values. You have MF values here, okay? Capital M values here. Just substitute all the values and give me the value.
35.60.
35.60. Okay. Let us halt for a second. In the previous problem which we have solved, the first problem which we have solved, okay, M value according to Rajat was 30.15, and most of you have
Yes,
said
the same.
28.05. So which one is correct?
30.15, sir.
30.1.
0.15.
30.15. So most of you are saying the correct answer is 30.15, but okay. So just change this, okay? Just change this in your notes to 30.15 because I don't have the values. I have to do it manually. 30.55. Accordingly, change the R value also. If M value changes, what happens? Even the R value changes, is that? So here it changed and here it changed. So it was what? 30.15. Now give me the new R value for this.
0.27.
0.2757.
275. Okay, this was one thing. In the second problem, Srijan gave me this value, the sigma A cross M. Guys, beyond time. Sigma A cross M of the previous problem, that is the second problem, was not 16.52, but instead it is 16.11 according to Srijan. So which one is correct?
16.11, sir.
16.1.
16.1, sir.
Okay, so
As we
accordingly,
have written same.
yeah,
We have written 16.1 itself.
that's good. So change the value to 16.11. Accordingly, give me the value for M and R, because M and R value also changes over there. You change the entire thing. What is the value of M? F sigma A cross M is 16.11.
16.1035.
16.135.
1035.
1035. This is
1035.
1035. Very good. R value.
0.5163.
Point.
516. That's great, guys. That's great. So those are the changes. At the last, at the end of the class, someone instructed that. So just gone through it. Okay, now M is done. MF is done. Still, what you have supposed to calculate? Yes, man. R we are supposed to calculate now. Okay.
0.2335.
How will you calculate it? As R bar by capital M. So just substitute the value and give me the value. How much?
0.2335.
0.2335. The unit is kilojoules per kg Kelvin. Okay, so that is the unit of R. Now, you need to calculate the partial pressure of each component, is it? The partial pressure of each component. Now, how will you do it? I just explained this. Please be in touch. Okay. Wait a minute. What's the result? Okay, now listen here. So the total pressure is given in the problem, the pressure of the mixture, whether it is given in the problem, how
Yes,
much
sir.
it is.
100
So
kilopascal.
100 kilopascal kPa. Now look here. So if I want to calculate the partial pressure of A, okay, how will I calculate? It is the mole fraction of A multiplied by the total pressure. Similarly, if I want to calculate the partial pressure of B, how will I calculate? It is mole fraction of B into your partial pressure. Similarly, if you want to calculate partial pressure of C, how will you calculate it? As mole fraction of C into the total pressure. I guess you know the value of the total pressure it is. Now you have to know the value of what is N of A, N of B, and N of C. So if you get the values of the mole fractions of the constituents, you will get the partial pressures of the constituents. That is the funda. So how will you get this values of the mole fractions?
Number of constituents of gas A divided by total mass, total mole of gas mixture.
Okay, fine. So I'll just take a page. So NF is nothing but, I mean to say, to be specific, NF of A is nothing but N of A divided by total N. Now, I should calculate NA and N. How will I do it? Number of moles of gas A and number of moles of the mixture. I have to calculate. How will I do it? Yes. Okay. The concept of calculating the mole fractions of individual constant will be taught in immediately next problem, which is this. Okay. Till then, there is a funda. See, mole fraction is coincided with the volume fraction, is it? So when you consider a mass as your priority, then you'll get a mass fraction. When you get volume as your priority, then you'll get the mole fraction. So the mole fraction always corresponds to the value of what? Volume fractions. Do you know the value of volume fractions here, which is nothing but the mole fractions? He has given in the problem, yes or no? So all these values, if you see here, all these values are what? These are the values by volume. That is nothing but the mole fraction, nothing but the volume fractions. Is it? You can consider these values to be what? NF of A, this to be NF of B, and this to be NF of C. Since these are the percentage fractions by volume, corresponds to the mole fraction values of the things. Got the things. So now you have the value of NF of A, you have the value of NF of B, similarly you have the value of NF of C. Now I think the calculation of partial pressure is not a big deal here. So you have the total pressure, you have the NF of A values. Give me the value of PA, PB and PC now. How much?
30.
30. That's it.
40. Foot.
40. And even this will be 30
30.
kilopascals. So the partial pressure of A is 30, the partial pressure of B is 40 kPa, and the partial pressure of C is 30 kPa again. So Dalton's law is equals to PA plus PB plus PC. So that will be satisfied anyhow. So this is a simple problem in order to understand the mole fraction. To completely understand the mole fractions concept, the next problem is that where, see, this is important, guys. Listen. So until now, how many problems you have solved? Three problems. Is it? In all the three problems, what we have done, they used to give us the more volumetric analysis. I mean to say, they used to give us the volume fractions. We have calculated the mass fractions out of it. That means you have converted the volumetric analysis into the gravimetric analysis, the mass analysis. From now, the few problems will be there where there will be giving you the masses of the individual gases. That means the mass fractions of the individual gases. You need to calculate the volumetric analysis. That means the gravimetric analysis of the gas constituents will be given, and you need to figure out what is the volumetric analysis of such gases. The exact ulta of such problems would be there. So just take this problem. Yes. Give me your attendance, Abdul Rahim.
Sir, is to be the
Procedure.
gravimetric analysis of air is to be
Is to be taken as. Is to be taken as. Okay. 23.3% of oxygen. Even he has specified the molecular weight as 32, and 76.7% of nitrogen with molecular weight 28. Okay. Next, Akash. Bharatesh.
Present, sir.
Devdutt.
Present, sir.
Present, sir.
Shahid.
Present, sir.
Wasim.
present, sir.
Srijan.
Present, sir.
And Kumar. Kishan Kotian.
Present, sir.
Lakshmi.
Present, sir.
Malatesh.
Present, sir.
Roy. Marvin.
Present, sir.
Muhammad Khalid.
Present, sir.
Muhammad Munawar.
Present, sir.
Mohan Chandra.
Present, sir.
Muhammad Surei. Nishan.
Present, sir.
Ritesh.
Present.
Numan. Pradeep Shetty. Praveen.
Yes, sir.
Syed.
Sir, Mohammed Sir present.
Okay, Muhammad Surey. Which class is this one, Muhammad Surey? Which class is going on?
BTD.
Thanks that you know that. Right. Raj Prasad. Rakesh. Raj Prasad is there, okay. Rajat. Right, is not there. Pradeep Shetty. Not there. Numan. Not there. Okay. Fine. Done taking the question.
Yes, sir.
Okay, now listen here. I have already solved it because in order to because now from now on the problems become a little bit lengthier to do it. So just I'll be already solved it on here on the screen. So I request all of you to just see, okay, and keep your calculators with you. So what he has given here is okay, a vessel of 0.35 meter cube. Yes. Just read out the question once again. So the vessel of 0.35 meter cube, correct? So the vessel, this thing, the volume he has given it is 0.35 meter cube. Okay, contains 0.4 kg of carbon monoxide, which has a molecular weight of 28. That means it has a carbon monoxide, okay, which has a carbon monoxide which is of 0.4 kg. Now at 20 degrees Celsius, so nowhere I guess the temperature would affect us. So just take it, so convert it into Kelvin and keep it. Okay. Now, that much only he has given. Next, the partial pressure of each constituent you have to calculate. The total pressure of the vessel you have to calculate. The gravimetric analysis for air is to be taken as. That means it is a mixture of carbon monoxide and air. So this component is CO and air. And air again, it has a two components in it as he has specified in it. So 23% of oxygen is there and 76% of nitrogen is there, and this percentage is by the mass. Okay, is by the mass. He has specified here as 1 kg of air, is it? So carbon monoxide is 0.4 kg, whereas air is 1 kg. In that air again you have oxygen and nitrogen. Oxygen percentage being 23%, nitrogen percentage is being 76% by mass. Remember this, this is by mass. Suppose if the air is of 1 kg, okay, if the air is of 1 kg here, now 23% of 1 kg is your oxygen weight, correct? Got this thing, Mas? This is very important. 23% of 1 kg is your oxygen weight. Similarly, 76% of 1 kg is your nitrogen weight. Yes or no?
Yes, sir.
Got this point?
Yes, sir.
It's simple aptitude, man. Huh?
Yes, sir.
Yes, sir.
23% of 1 kg is your oxygen weight. That means what is 23% of 1 kg? 0.23, is it? So the oxygen
Yes.
weight is 0.233 kg. Similarly, 76% of 1 kg. What is 76% of 1 kg? It is 0.76 into 1. So again it is 0.76 kg. If you add these two, again you'll get back 1 kg, man. Got my point?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So finally, how many constituents you are having?
Two.
3.
Uh-huh.
Three, sir.
Two, three. You have forgot carbon monoxide. That is very important. Why this problem? It's a little bit what I appreciate the problem creator, man. It has been asked way back in 2012. Okay. This is a nice problem. He says zero point 0.4 kg of carbon monoxide is there. Fine. So that is your first constituent, 0.4 kg. And air, he says, air has two components. One is oxygen, which is of 0.23 kg, and one is nitrogen, which is of 0.767 kg. So altogether, how many constituents you have? You
Three.
have three
Three.
constituents, and even you know the gravimetric analysis, the mass distribution also. Carbon monoxide 0.4 kg, oxygen 0.23 kg, nitrogen 0.76 kg. The total mass is what? 0.4 plus 1 kg, it is 1.4. Correct? Got my point? Up till now is clear.
Yes, sir.
Yes, sir.
Now,
Yes, sir.
okay. Now we have to calculate the partial pressure. For that, what you'll be doing, you'll be taking the ideal gas equation. So that is PV is equals to mRT. Again, R you can write it as R dash by M, correct? You can write it as R dash by M. Now, for this, what I'll be doing, I'll be transferring volume to the either side. I'll be transferring volume to the other side so that I can calculate what is the total pressure. Total pressure is mass R dash T divided by capital M. Okay. In this particular equation, this is for the total pressure. Okay. Hence, for the individual constituent, what I'll be doing it is Pi is equals to Mi into R dash T divided by MIB, because V, T and R dash are common for all the constituents. The only thing which changes is your mass of that individual constituent and molecular weight of that individual constituent. That is the one thing that changes. So similarly, now, if I want to calculate the partial pressure of O2, that is PO2. So what is the expression? Mass of O2 into R dash T divided by capital M, which is molecular weight of O2 into V. Let us see what all we know and what all we should calculate. Whether I know the mass of O2, whether I know the mass of O2,
Yes, sir.
Yes, sir.
very good.
Yes, sir.
Whether I know the molecular weight of O2, that you have to
Yes, sir.
remember, that will be not
Yes,
given.
sir.
You know, it has 32. Whether I know the value of R dash, which is R bar,
Yes, sir.
Yes, sir.
8.314.
Yes,
Whether I
14.
know the temperature value he has given.
Yes.
Yes.
Okay. Whether I know the volume of the mixture.
Yes,
Yes,
sir.
sir.
Yes,
Since
sir.
everything is known, whether I can calculate the partial pressure of O2 here.
Yes, sir.
Similarly, guys, it is same for N2, where you have to substitute the mass of N2 and molecular weight of N2. Molecular weight of N2 is what? 28. Yes, the mass of N2 you have calculated here. And it goes same thing for the CO also. CO is mass of CO into R dash T divided by capital MCO. So mass of CO you have calculated, he has given, you are not calculated, he has given it as 0.4 kg. Okay. Next, capital M of CO, 28, you know, just substitute the values and you'll get the partial pressure of N2, CO and O2. Now, how am I supposed to calculate? I know there are three constituents. I have calculated the values of partial pressures of all three constituents. Now I need to calculate what is the total pressure of this mixture of three constituents. How will I do it? Add, simple. Why? Which law helped you in understanding this? That is P exactly. So if you add all these three, you will get the total pressure of the mixture according to the Dalton's law, same which I have applied here to get the total pressure of the mixture. Any difficulty in understanding this problem, guys?
No, sir.
No, sir.
Okay. So now take the problem. Okay. I'll put it in a portrait mode for some time. Can you see it? First you take this, but can you see it clearly?
Yes, sir.
Take down. Yes, okay. Rajat is Medival. Rakesh GM. Okay, Rakesh is present. Ramachandra.
Present, sir.
Pratik Lobo.
Present, sir.
Syed Anwar.
Present, sir.
Sohan.
Present, sir.
Siddesh VN.
Present, sir.
Saurabh Shetty.
Present, sir.
Srinivasan not there. Okay, Stephen.
Present, sir.
Sujan.
Present, sir.
Shant.
Present, sir.
Vaibhav. Varun.
Present.
Okay. Vignesh.
Present, sir.
Marvin. Marvin. Wayne.
Present, sir.
Baruch.
Present, sir.
Shiran.
Sir,
Dave.
not
Hello,
completed,
sir.
sir.
Hello, sir. Which Marvin did you say, sir?
Yes.
Hello.
Yeah, Marvin.
Yeah, which Marvin, sir? Marvin Pinto or Marvin Lance, sir?
Okay, Marvin Pinto is also there.
Yeah,
Okay,
I am
Marvin
Marvin Lance,
Lance.
sir.
Marvin
Yeah,
Yeah,
Lance.
sir. Good to know.
Okay, okay. Fine, fine.
yeah, Marvin Lance is present, sir.
Okay, okay. Swaroop.
Yeah,
Marvin
thank
Pinto
you.
also present.
Present,
Okay,
sir.
man. Both of them are present.
Sir,
Swaroop present. Shiran.
excuse me, sir.
Akash, ಹೇಳು.
Sir,
Hmm.
I am present, sir. Here network issue due to rain, sir. I exited twice and I didn't return.
Okay.
Vaibhav
Next,
present sir.
Shiran. Shiran
Present
is
sir.
there.
Present sir.
Okay. Mandan.
Present,
Muhammad
sir.
Khalid, switch off your mic. Darshan Shetty. Prakhyath.
Present, sir.
Okay, Darshan is Shetty present. Prakhyath. Praveen Nair. Praveen. Abdul Sami. Aditya Shetty. Amal PK.
Present.
Okay. Amal PK.
Yes, sir. Amal present.
Amok P. Hekade.
Present, sir.
Chandan Rao P. Why this guy is not attending the classes, man? Okay, he initially is not attending. Okay, fine. Chirayu.
Present sir.
Cyril Vikas.
Present, sir.
Darshan S. Shetty. Sorry, Darshan Shetty.
Present, sir.
Okay, pa. Midlaj.
Sorry, noted my name, sir. Right, Amal.
Amal, I have called when I have marked.
Okay,
Midlaj.
sir.
Present, sir.
Okay.
Sir,
Narendra.
ಕೆಲಗಡೆ sir. ಬರ್ದಾಯ್ತು.
Hmm.
Present sir.
Omar
ಸರ್
Zaiban.
ಸ್ವಲ್ಪ ಮೇಲೆ ಸರ್ ಫಾಸ್ಟ್ ಹೇಳ್ಬಿಡಿ.
Present, sir.
ಏಯ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ ಯಾಕ ನೋಡಿ ಬರೀತೀಯ ನೀನು ವರುಣ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಇಲ್ವಾ ಗೊತ್ತಿಲ್ವಾ ಹೇಗೆ ಮಾಡಬೇಕು ಅಂತ calculate all of you man not only Varun try to calculate and then write see the screen just for your reference man don't just keep on copying it okay I told you in the initial stages of the class itself dedicate 1 hour for the class that's enough okay whatever we solve in the class just do it sincerely okay you will learn once you revise during the examination that's enough so that's why just keep this whatever I will be showing as a reference uh, you try to solve on your paper okay Pratik Kesi
Yes, sir.
Rachanar Shetty
Present, sir.
Desh Kumar
Present, sir.
Vishnu Raj okay fine completed the problem
No, sir.
ಬೇಗ ಬೇಗ ಮಾಡಿ ಟೈಮ್ ಆಗ್ತದೆ
Sir, Muhammad Khalil present, sir.
ಓ ಕಣ ನಿನ್ನ ಮಾರ್ಕ್ ಮಾಡಿದೀನಿ
Thanks, sir.
ಮಾರ್ಕ್ ಮಾರ್ಕ್ ರಾಕೇಶ್ ಎಂ ಮಾರ್ಕ್
Vaibhav Naik sir. Present sir.
ವೈಭವ್ ಮಾರ್ಕ್ okay shall we move to the next Vaibhav will be marked absent one. Okay, network issue he has stated. Make it fast, guys. Okay, done?
Yes, sir.
Next, there is a similar problem. I want answers from you. Okay. Just try this. Again, you can see the same problem, how many times it has repeated. So it has the data up till 18 only, but even in the 19 Jan, I think it has been repeated, the same question. The mixture of 3 kg and 5 kg is a most popular question. Has 3 kg of nitrogen, 5 kg of carbon dioxide, very much easier than the previous. Okay. He has given all the things, and he has asked us to calculate the mole fraction of each constituent, equivalent molecular weight, equivalent gas constant, and all. One thing we shall do. What we shall do is I will be explaining the problem. Okay, since I have written it already. Okay, and I'll be sending you you can take the screenshots at the last. Okay, you can take the screenshot and then you can update. Is that fine?
Yes, sir.
Now take the screenshot of the problem. Okay.
Yes, sir.
Maybe just all of you take the screenshot. I give you 5 seconds. Done? Okay. So now, just relax and keep watching whatever I explain. Okay. So in the problem, what he has given that there is 3 kg of nitrogen and there is 5 kg of carbon dioxide. The pressure of the total mixture is 300 kPa and temperature is 293 Kelvin. So this is what he has given. Similarly, what you have to do, you have to construct a table. What you have to construct? First gas, A gas, you have dedicated A gas to be the nitrogen, and carbon dioxide you have considered as the gas B. So mass of A he has given as 3 kg, mass of B he has given as 5 kg. Suppose mass of total mass, what it will be? It will be mass of A plus mass of B. So 5 plus 3 is?
8 kg.
So 8 kg is the mass of the mixture. Okay. Now, how will you calculate? How will you calculate the mass fraction of A? How will you calculate the mass fraction of A? Yes, how will you calculate the mass fraction of A? The masses of the individual constituents is given, total mass you have calculated of which is of the mixture. So how will you calculate the mass fraction of A?
Divided by 100.
Hoi. ಇದು ಟೋಟಲ್ ಮಾಸ್ ಇದೆ ಆಯ್ತಾ ಇದು ಮಾಸ್ ಕೊಟ್ಟಿದ್ದಾನೆ ಅವನು ಪರ್ಸೆಂಟೇಜ್ ಕೊಟ್ಟಿಲ್ಲಲ್ಲ
8 by 3.
Exactly, man. Very good. So it is not 8 by 3, it is 3 by 8.
Okay.
Similarly, yeah. Mass of a constituent divided by mass of the mixture. That is the mass fraction of A. Similarly, the mass fraction of B. Mass of B divided by the total mass of the mixture. So, ಇವಾಗ ಇಲ್ಲಿ ಏನಾಯ್ತು ಈಗ mass of A is to 3 kg, total is to N2. So what is the mass fraction given the value? And similarly, mass fraction of B is 5 and mass of B is 5 and the total mass is 8. So mass fraction you can calculate similarly as such. So ninge ಏನು ಬರುತ್ತೆ mass fraction of A ಬರುತ್ತೆ, mass fraction of B ಬರುತ್ತೆ. So that is what I have done here. Okay. Calculation of mass fraction. How will you do it? Mass fraction of A is mass of A divided by mass of mixture. 3 by 8, it is 0.375. Similarly, mass fraction of B, it is MB by M, which is mass of B divided by mass of mixture. So 5 by 8, 0.625. Okay. Any doubts here?
No, sir.
Okay, next. calculation of number of moles. What you have to do now is number of moles of A you have to calculate. You know that number of moles is divided by mass of A divided by molecular weight of A. Okay, how will you get it? So in the sense, so molecular weight, how will you define the molecular weight? It is mass divided by number of moles, is it? You remember this, right? So molecular weight is nothing but what? Mass divided by number of moles. ಈಗ ನಾ ಎಂತ ಬೇಕು ನನಗೆ number of moles ಬೇಕು. So you have to divide mass with molecular weight. That is what I have done here. Okay, so n of A is equals to small ma divided by capital Ma. Small ma here is given as 3 kg. Capital Ma of A is what? A is nitrogen, I guess. Correct? No? Nitrogen. No? A is the nitrogen. So capital Ma would be 28. So 3 by 28. So 0.107 is n of A. Similarly, calculate n of B, which is Mb divided by capital Mb. Small mb is mass of B, which is 5. Capital MB is molecular weight of B, which is carbon dioxide. Molecular weight is 44. Then you'll get N of B. How will you calculate the N of a mixture? Na plus Nb. Add these two, you will get this value, which is 0.22. Any doubts in calculating number of moles? ಅರ್ಥ ಇದೆನ್ರೋ?
Yes, sir.
Yes, sir.
ನೆಕ್ಸ್ಟ್ ಈಗ ಮಾಸ್ ಫ್ರಾಕ್ಷನ್. ನಿನಗೆ ಎನ್ ಎ ಗೊತ್ತು, ಎನ್ ಬಿ ಗೊತ್ತು, ಓಕೆನಾ, ಅಂಡ್ ಎನ್ ಗೊತ್ತು. ಎನ್ ಎ ಗೊತ್ತು, ಎನ್ ಬಿ ಗೊತ್ತು, ಅಂಡ್ ಎನ್ ಗೊತ್ತು. ಎನ್ ಎ ಇಸ್ number of moles of gas A, Nb is number of moles of gas B, N is number of moles of the mixture. ಅದರದ್ದು ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀಯಾ? ಇಟ್ ಇಸ್ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಗ್ಯಾಸ್ ಎ ಡಿವೈಡೆಡ್ ಬೈ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಅ ಮಿಕ್ಸ್ಚರ್. ಇದು ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ ಗ್ಯಾಸ್ ಬಿ, number of moles of gas B divided by number of moles of the total mixture. ನಿನಗೆಲ್ಲ ಗೊತ್ತು, Na ಗೊತ್ತು, Nb ಗೊತ್ತು, N ಗೊತ್ತು. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ NF of A, which is the mole fraction of A, and NF of B, which is the mole fraction of B, you will get. Okay, any doubts here? ನಿನಗೆ moles ಗೊತ್ತಾದ್ಮೇಲೆ when you get to know the moles, mole fraction calculate ಮಾಡೋದು easy. Okay.
Yes, sir.
Okay. This you have already done. Calculating the molecular weight, is it? Calculating the molecular weight of the mixture. So how will you do it? Capital M is equals to 1 divided by MF of A divided by MA, MF of B divided by MB. You know all the values of MF, which is mass fractions, and molecular weight. You will easily get what is the molecular weight of the mixture, which is capital M. Again, the gas constant, same you have done in the previous problem. Just divide R bar by capital M. So R bar value we know as 8.314. M value you have just calculated. Substitute it, you'll get the value of R. Calculation of partial pressure. In the previous problem, I have told you Ti is equals to NF of I into P. NF of I ಗೊತ್ತೇನ್ರ ನಮಗೆ? Do we know the value of NF of A and NF of B? Mole fraction of A and mole fraction of B, do we know the values?
Yes, sir.
So if you know the value, total pressure is being given in the problem as 300. Just multiply corresponding mole fractions, you will get corresponding partial pressures. That's it. That completes the problem, guys. Any doubts in this?
No, sir.
Simple problem. Oh. Okay, you can take a screenshot until here. I will say, you can take now. Taken?
Yes, sir.
Next.
Yes, sir.
Until here, one more. Done?
Done, sir.
Everyone has taken it?
Yes, sir.
Yes, sir.
Yes, sir.
And the last one. Okay.
Yes, sir.
Okay. So there is one problem left which is very good. When there are a couple of problems, if time permits, we shall solve. So this particular problem is there, which asks you the every parameter, man. If it is asked in the problem, it is definitely will be for 30 marks or 40 marks, which will be not be given. Any of the two will be given. Calculate this or this or this or this or this or this, something like that. So in this problem, what I have done is I have incorporated all the possible values he may ask you to calculate in your examination. That means what it makes sense is if you just understand this problem, if you just solve this problem, so it is equivalent to that you have solved all the problems in this module. That is how I have designed this particular problem. Okay, so just take a screenshot and keep it updated by the next class. And I want everyone to solve this. I guess a mole fraction of the each constituent can be solved. Equivalent molecular weight can be solved. Gas constant can be solved. Partial pressures can be solved. Volume density of the mixture, it is a new concept. And CP and CV values of the mixture is a new concept, which will be taught in the next class. Only these two aspects, 5 and 6. I will tell you how to calculate it, but I want everyone to calculate 1, 2, 3, and 4. Is that clear, guys? In the next class, not now. Is that clear?
Yes, sir. Yes, sir. Yes, sir.
Be ready for the next
Yeah.
class to calculate
Yes, sir.
1, 2, 3, and 4. Okay, just take the screenshot and update it in your notes. We shall meet you in the next class. Have a great day ahead. Take care, guys.
Thank you.
Sir, attendance.
Thank you, sir.
Attendance
Thank you,
question,
sir.
Vignesh, present.